Good morning, everyone. Let us start this session. So today I will start the module number 5, which is a force vibration. So the last two modules, that is the module number 3 and module number 4. So they were based on the free vibrations. Okay. So meaning of free vibration is we provide the force only at the initial condition. That means we give the initial displacement and then we release the force and the system oscillate by its own because of the inertia forces and the spring forces. Okay. So this oscillation, this is called as a free oscillation or the free vibration. So what is meaning of force vibration? So when a mass of the vibratory system is continuously excited by a harmonic force, such vibration are called as a force vibration. Okay. So continuous excitation means we will provide a continuous force to the mass, and under this force, the mass will vibrate continuously. So such oscillations, they are called as a force oscillation or force vibration. So harmonic force means for the force, its direction is continuously changing with respect to time. Okay. So this force, that is a harmonic force, it will have the equation which is similar to the harmonic equation for the displacement. So for the displacement, we have the equation which is x is equal to a sine omega nt. Okay, that means this displacement x, it is changing with respect to time t, and a, it is the maximum value of the displacement, that is called as the amplitude. So similarly, for the harmonic force which will be acting on the mass during that vibration, its magnitude, which is f, it is given by this equation. F is equal to f0 sine omega nt. So f0, it is the maximum value for that force, and this value f, this is a value at any time t, it is changing with respect to this time. Okay. So sometimes the force vibrations, they are required in the machines to perform a specific task, and for some machines this force vibration causes noise and machine failure. Okay. So the aim to learn this topic, that is a force vibration. So first is how we can create a force vibration in the machine so that we can achieve the desirable amplitude and the force. Okay. That means wherever if you want to create the force vibration in the machine, how we can create that force vibration. And the second, how we can minimize the effect of the force vibration by designing proper isolation. That means we should design a proper shock absorber so that we can minimize the noise and the machine failure. So these are our two main aims to study this topic, which is a force vibration. So now we will see some of the application areas for the force vibration. So first is the designing an isolation for vibrating machines like pump, compressor, then IC engines, turbines, etc. So you can see here in the second image, so this is the pump assembly. So this pump, it is driven with the help of this prime mover, which is a motor. And this complete assembly, it is mounted on the foundation. Okay. And this assembly is separated from this foundation by using this isolator. So isolation is basically a spring and damper arrangement so that we can minimize the force transmitted to this foundation. Okay, and then we can avoid the noise and the failure of the machine components. Okay, so in order to design this, so you can observe here, these are the different isolators. So we should study this force vibration to design such isolating mounts. Then second application is selection of proper spring and damper for the automobile suspension. Okay, so in order to reduce the shock transmitted to the rider, we have to design a proper suspension. That is, we should select a proper spring and proper damper. So to design this spring and damper, we should study the force vibration. The next application area is designing the vibratory conveyors, then jackhammers, then drill machines. So in all these machines, that is a vibratory conveyor, jackhammer, drill machine, there is a spring and damper arrangement. So you can observe in the first image. So this is one vibratory conveyor. So these are used in the mining industries. So observe the second image. So generally, such type of conveyors, which are vibratory conveyors, they are used for the sorting the different parts So for this vibratory conveyor, there has to be a specific amplitude and the force, okay, for this conveyor. So this amplitude and force, it is created with the help of this spring arrangement. So this spring is connected with this conveyor, and the force vibration or the force is created with the help of a motor. So we will study this in detail. This is a rotating unbalance. Okay, so these are some application areas why we should study the force vibration. So now we will start with the actual mathematical modeling for a simple force vibration. So our aim is for this mathematical modeling for the force vibration. So we should find out the equation for the displacement of the mass when the mass is excited by a continuous force, which is F. Okay, that means if you supply a continuous force F on the mass for a vibratory system, then what is the effect of that force on the displacement? So this effect we can study with the help of the equation of the displacement, that is a X. And second, so this force actually it is a harmonic force. So it will have the equation F is equal to F0 sine omega t. That means the force is changing its direction by this frequency omega. Okay. So we will study what is the effect of changing the frequency, which is the external frequency for this force. It is not a natural frequency. So what is the effect of changing the frequency of the force on the displacement? Okay. So for these two reasons, we will find out the mathematical equation for the force vibration. So first case that we will discuss, it is a simple force vibration. Okay. So here I have shown one schematic diagram. So this is the mass M. So it is connected with the help of a spring and damper. So this spring, it is having the stiffness K, and the damper, it is having the constant C. Okay. Now just imagine this mass is being excited by an external force. So this is the external force whose equation F is equal to F0 sine omega t. Okay. So because of this force F0 sine omega t, this mass will start oscillating about its mean position. So suppose this is the mean position. So it will oscillate in this direction continuously as long as this force is acting on the mass. Okay. So this displacement, let us take this as a x, and it is changing with respect to time. So we should find out the relation for x, or equation for x, which is a function of time. Okay, so this is our first aim. So we can find out this equation by equation of motion for this force vibratory system. Now this schematic diagram we can also represent in this way. Okay, so this is the fixed support, then this is the spring and damper, so C and K, and this is the mass. So this mass is being excited by a force which is F is equal to F0 sine omega t. So omega is the force frequency. So let us see how this mass will oscillate. So this is the oscillation of the mass under this action of the force F0 sine omega t. Now for this oscillation, we should write the equation of motion. So we will use the Newton's second law to derive the equation of motion. So this is the schematic diagram for a simple force vibration. Now this mass is being excited by the force which is a F is equal to F0 sine omega t. And this is the displacement which is a x. Okay. So for the Newton's second law, we should draw the free body diagram. So as the displacement x in the downward direction, so its inertia force, which is a mx double dot, it will be in the same direction of the displacement x. This spring force and the damper force, they are in the opposite direction to the displacement. So this is the first vector, which is the spring force, which is a kx in the opposite direction to the displacement. And similarly, the damping force, which is cx dot, it is also in the opposite direction. Now this f0 sine omega t, as we have taken this vector in the downward direction, so this is the exciting force, which is a f is equal to f0 sine omega t. Okay, and then write the equation of motion by using Newton's second law. So by Newton's second law, the equation is summation of f, this is equal to mass into acceleration. Okay, so summation of f means we should consider all the external forces, including this f0 sine omega t. Okay, so first is the kx, so we should only consider y direction, there is no force in the x direction. So even we can write this equation as fy. So first is the kx, it is in the positive y direction, plus cx dot, it is also in the positive y direction. Then this f is equal to f0 sine omega t, it is in the negative y direction, so it is minus f0 sine omega t. And this mass into acceleration, which is the inertia vector, it is also in the downward direction, so it is minus mx double dot. Okay, now just rearrange the equation. Take this inertia mx double dot on the left hand side, so it is mx double dot plus cx dot plus kx, this is equal to, take this term on the right hand side, which is f0 sine omega t. Okay, so this is called as the equation of motion for the simple force vibration. So this is not equation of displacement, it is just an equation of motion. So meaning of equation of motion is, it will show all the forces which will cause the vibration of the mass. So it has first term, it is the inertia. So this is the inertia force. This second term, it is the damping force. This third term, which is a kx, so this is the spring force. And the right hand side, which is a f0 sine omega t, this is the external force. So this is external harmonic force. Okay, so meaning of harmonic force is, it is changing the direction continuously with respect to time with specific frequency, that is the omega. Okay, so after this equation of motion, we will try to find out the equation of the displacement. Okay, so we will use the d operator method to find out the equation of displacement. So we should find out the equation of the displacement, which is a x so for that we have the equation of motion, which is a mx double dot plus cx dot plus kx, this is equal to f0 sine omega t. Okay, so this is our reference equation, that is the equation of motion. Now we will write this equation in the differential form. So before that, just rearrange the term. Take this mass. So divide complete equation by the mass. So we will get the equation like this: x double dot plus c by m x dot plus k by m x, this is equal to f0 upon m, okay, into sine omega t. So actually this f0 sine omega t, so if you plot the waveform, so if this is the system, and if you are supplying the force f0 sine omega t, so this is the f. So the force graph, it will be like this. So it is the harmonic motion for the force. This maximum value on both the sides. So this is nothing but the f0, which is called as a force amplitude. Okay. And this is the time period for that force. So from this time period, we can find out the frequency omega is equal to 2 pi upon t. So omega, it is the external frequency of excitation. Okay, so it is a frequency with which the force is changing its direction. Okay, so after this, we can write this equation as d square x upon dt square plus c by m dx by dt plus k by m, this is equal to f0 upon m sine omega t. Now just replace d by dt by d operator. So by using d operator, so our equation is d square x plus c upon m dx plus k upon m, this is equal to f0 upon m into sine omega t. Okay, so sorry, this is a x, so take x common, so we will get d square plus c upon md plus k upon m into x, this is equal to f0 upon m sine omega t. Okay, now this complete equation or solution of this equation, which is a x, so it is written as x complementary function plus x particular integral. Okay, so here this equation as right hand side, it is a variable term which is a f0 upon